Hi, today I wanted to talk to you about solving some more trig equations. We're going to solve for as many answers as it takes in radians between 0 and 2 pi for the following trig equation. And I wanted to choose one that was a tangent equation because it has a different fundamental period than sine and cosine. So we're going to solve for tangent. I wanted to notice that there has been a couple changes to this tangent. Its amplitude has been changed and its period has been changed. So we're going to tackle first the notion of what its new period is. So we're going to do pi divided by b, and b happens to be pi over 2, and that's going to work out so that the new period of tangent is going to be 2. Also, there's been some sort of amplitude change we can see by the 1/2 in front of the graph. That means this is just going to be like a squatter tangent graph. All of the y values will be multiplied by 1/2. And to address the period, if the period is 2, it's going to do a whole tangent in the range of 2. And so it's going to go from -1 to 1 on the x-axis so that it can still cross at 0 and have a solution at 0, 0. So let's go ahead and start solving. We're going to set the equation equal to 0. We'll multiply both sides by 2. And that's going to simplify out. Now we're going to take the inverse tangent. Now be real careful here. When we take the inverse tangent of 0, like so many of the other trig functions, we're going to expect that there be 2 answers. Okay, so, and these 2 answers we can find exactly. We'll think about what the unit circle looks like and where those 2 answers exist. So at the point 1, 0 and the point -1, 0, the y over x value will give me 0, and that's going to be where tangent is going to equal 0. So I'm going to set pi over 2x equal to 0, which is the first answer. I'm going to add plus pi n so I can generate multiple answers. And the next answer, where pi over 2x equals, is going to be pi. And then we add the plus pi n as well. So we add the period n. And now we get to isolate the x. Mathematically, we're going to multiply both sides by 2 over pi. Okay, we'll distribute that. And notice our equation gets much more simplified now. The pi's cancel out, and we get x equals 0 plus 2n, and x equals 2 plus 2n. And we need both of those equations to generate all of the possible answers. Now we're just going to let n be integers. We can let n be as many integers as we need to get all of the following answers. So when n is 0, and we plug that in, our first two answers is 0 and 2. Then we're going to let n be 1, again plugging in, and we get 2 and 4. And then we'll let n be 2, and we get 4 and 6. And then what the heck, we'll let n be 3, and we'll get 6 and 8. Now we know that we only need to go up to 2 pi, which is a little past 6.28. So we don't need the last answer. And then there's a couple of repeat answers. And there's 4 answers total in that range. Okay, so now I'm going to show you what the graph looks like so that we can see that, yeah, there should be 4 answers. So first we'll put the asymptotes in. And remember, we've had a period change, so there are no pi's on this axis anymore. And so every single one of these tangents will be graphed with a period of 2. And we can see within that range, we end up with those 4 answers, 0, 2, 4, and 6. Thanks.